person is digging a hole for a fence post. So the post is 8 feet long, and they suggest that you dig a hole that's a third the length of the post. So you got a fence post. It looks like this. It's got a square top. That's the best you're going to get from me. Okay, that's a piece of wood. You're putting it in the ground, right? So here's the ground. They want this portion to be a third of the entire height of the fence post. So how deep should this hole be? This part right here needs to be a third of 8. So to find a third of a number, we multiply by 1/3. So all we need to do is we need to calculate 8 times 1 divided 3. So we got roughly 2.667 feet. So in real life, maybe you'll just go for 3 feet. So part 2 says that the post, just like the one I just drew up here, well, it's not quite square, but it's supposed to be a square base. So here's the base of the post. If you put it flat on the ground, this is what it would look like. It's 3.5 inches for each side. So they're saying make the diameter of the hole that you're digging into the ground to be 3 times the width of the post. So we're making a circular hole because it's got a diameter, goes all the way across. This diameter needs to be 3 times the width of the post. So the diameter needs to be 3 times the width of the post. So 3 times 3.5. So the diameter of the hole is 10.5. And what are we, inches? Okay. That's it for question 2. Okay, that's building us up for question 3, which is much more difficult. Okay. Take it one step at a time with me, though, and you'll be all set. So they're going to fill the hole with concrete. Okay, the concrete comes in these bags, and the bags estimate that they'll cover 0.375 cubic feet when mixed with water. So we'll want to keep that in mind because our dimensions above were in inches. So a fence post hole is suggested to be 3 times the width of the post, just like above, a third of the length. Everything's the same as the first 2 questions. A person has a fence post at 3.5, so everything's the same. So how many 50-pound bags of concrete do we need to fill 20 fence posts that they're going to use for their fence around the yard? So the hole we just drew is going to make a cylinder in the ground. Okay, so here's the ground. The hole is going to go down here, and it's making a right cylinder. So we want to know the volume that we're filling in that cylinder. So the volume of a cylinder is found by taking the area of the base, which is a circle, so it's pi r squared, times the height, which would be this distance right here. That's actually what we calculated in part 1. So in part 2, we calculated the diameter is 10.5 inches. So the radius is going to be half the diameter. But before we do that, this is in inches. And I think our height in part 1 was in cubic feet, right? Because it was 8 feet long. Sorry, not cubic feet. This is in linear feet. So that should be 2.667 feet that we plug in for the height. So let's change our radius into feet while we're at it. So this is the diameter. So the radius is half the diameter. So that's going to be, I think that's 5.25 inches. So if we want to convert that into feet, we can use the fact that there's 12 inches in 1 foot. So I'm going to multiply by a conversion factor. 1 foot is the same as 12 inches. This is inches here, sorry. So those cancel. So I got 5.25 times 1 divided by 12. 5.25 divided by 12 is 0.4375. All right, so now we have the radius. It was in inches. We converted it to feet. So now everything is in the same units. We can plug it in. Otherwise, you wouldn't want to plug it in because then you're comparing apples and oranges. So this is, the height was 2.667 feet. All right, and so that's feet times itself times feet, so that makes feet to the third. That's our volume. Okay, so the order of operations says exponents comes first. Then we can multiply by this pi out here, and then multiply by the 2.667 feet. So we got the volume of the hole. It's 1.604 roughly. 1.604 cubic feet. Okay. That's the volume of the hole, assuming there's nothing in it. That'd be a lot of concrete, but we're filling up that hole with a post, right? We're putting a post in here. That's going to take up some of that volume. So let me try to draw that again real quick. Putting this post, you get the idea. It's a square base. That's not bad. Okay, so we're putting a post in there, which is going to take up some of this volume. So what we want to do is compute the volume of the post here. And that's easy because the area of the base is a square. So what was it? It was 3.5 inches, but we're talking about everything in terms of cubic feet. So the area of this base, let's convert 3.5 inches to feet. So 3.5 inches. I want to multiply that again by the same conversion factor, that 1 foot is 12 inches. That way the units cross cancel. So I got 3.5 divided by 12. That's 0.292 roughly. 0.292 feet. That's the area of the base, that's the length of the base of this post that we're putting in. So the area of the base would be length times width. It's 0.292 times itself, or you could just say 0.292 squared. So that's 0.0852, just carry out some decimals. That's square feet. That's the area of the base, and then to find the volume of this post, we take the area of the base, we multiply by the height. So the post is 8 feet long, but 8 feet of the posts are not within this right cylinder. It's not taking up that much area. It's only the height, the 2.667, that's within the right cylinder. So this part right here is 2.667 feet. So the volume the post is the area of the base times the height. So that's this many cubic feet. Round that up. Okay, so a lot of math has happened. We found out the total volume of the hole without the post was this up here, right? But when we put the post in, it's taking up this much volume. So the total volume that we need to fill up these, to fill up with concrete, is going to be the difference between the two. The difference of the hole without anything in it and the hole with the post in it. So that'll reduce how much concrete we have to use. So 1.3767. I've done a lot of work. Let me pause and check that before I go on. Okay, looks like that's what I got right from what I did earlier. That's the volume we need to fill per post. So these bags only take up 0.375 cubic feet. Let's move this up. Get rid of that. Move all this up. Okay, we're done with the volume of the post. I'm going to delete that. This is, so every post hole needs this much concrete. And we want to divide that by the number of bags, by the volume per bag, or you could use a conversion factor. This is cubic feet. And the question we want to answer is how many bags. So I'm going to multiply this by 1 bag per 0.375 cubic feet. Because 1 bag takes up 0.375 cubic feet. So these cross cancel. So we're left with bags as our units, which is what we wanted. So it's going to be 3.6712 bags per hole. So we'd obviously round in a real life situation about 4 bags per hole. But if we were to use the exact amount for 20 fence holes, we got 20 holes, and we said our calculations told us 3.67 bags per hole. And that's going to be about 73 bags of concrete. Maybe 74. We'd probably get 80 just to be safe, huh? A lot of concrete. 50-pound bag, I think last time I bought them, they were like $4 each or something like that. It's not that expensive when you think, like, in the grand scheme of things. But okay, so they got a lot of work to do. They're gonna have to mix about 74 bags of concrete for each of these holes, or find bigger bags. A friend of mine's suggestion was, when I was building my fence, because I had 40 fence post holes, he said just go pay a cement truck to just follow you from hole to hole and drop a little drop in each hole.